Welcome back. In the previous session, we discussed what is MLOps, what are the benefits of getting into MLOps, why MLOps, all these kind of discussions we have made. There are various methods and ways available for model deployment. There is no one generic method available as such. We are going to discuss these models and we can pick it up based on our requirement. The first approach is batch predictions. This is one of the simplest methods or ways to go ahead with the deployment. The main idea or crux of this method is very simple. The ML model is trained on the static data which shall be used to make the predictions. The data is stored in well-known databases like SQL. This can be easily integrated to the existing applications as well, and as and when required, the model needs to be retrained on the new data for getting perfect predictions. This approach is pretty much easy for all the beginners, and this shall be also very easy and fit for small scale applications and organizations. The major advantages of this batch prediction way of doing it is really easy to build, no complexity is involved, and very highly affordable. Disadvantages? Yes, there are a few. Latency is the major one. Complex ML systems cannot be deployed using this approach. This is not a right approach for complex ML systems. Well, the next approach is web service or REST API. This is the most famous or the most common approach. Web service or the REST API. There is no processing of bunch of records happen here. The essence really is it is one record at a point in time. It can also take inputs from the users and then can make the predictions. The output will be in the most preferred JSON format, and it is certainly very easy for the developers to integrate it into any of the existing applications. It is very simple and even gets triggered. A REST API passes the input parameters to the ML model, returns the predictions. That's all. It is very easy to deploy, it's affordable, and it's near real time. Disadvantages: some scalability challenges are cited, and security related threats are always cited in this approach. Mobile and edge devices based deployment. This is the most happening area, and a lot of research is going in this area. When you want a real-time response or action to be taken where there is no internet, ML models get deployed on these devices like mobile or edge. Edge devices can be anything. It can be your camera, it can be your smartwatches, it can be your microcontroller boards, and many more. The input data does not go to remote machines here. This is to be very clearly understood. The TinyML is one of the options helping in performing edge-based analytics with very minimal power requirements being needed. ML models deployed on the mobile devices are found to be pretty useful, and ML-based voice assistant, camera image-based attendance marking, deep learning-based or machine learning-based emotion-based feedback collection are simple examples. It is low cost, low power, and the size, the form factor is a major advantage. Hardware availability and resources availability is a major challenge. Real-time deployment is the next one. This must be real-time, means there is no delay. Every time the action has to be done on time, perfection is also to be there, and logical correctness of the operation within a deterministic deadline is expected every time. Once the input is sent to the system, in the real-time predictions are expected. It should work on the streaming data, and it's definitely not easy. The latency can be reduced by developing appropriate models using appropriate databases and caching predictions, and more approaches can be followed there. Advantage: this is definitely real time, and this is working on streaming data. No latency related issues or challenges are there. But disadvantages: this is certainly complex and expensive too. Thank you very much, and we'll come back with the next set of learning for MLOps, and I'm sure you like it. Thank you.